All right, good morning, everybody. It's still June 18th. It's about 9:55 in the morning now. What did I say? June 17th, I think is what today is. No, June 18th. Yeah, today is June 18th. That's what I've been saying in all the other videos. I guess this is the fifth video, and now I'm starting to question myself. It's June 18th, 2026. It's not quite 10 in the morning, and I'm going to finish up this series. This is the fifth video that I'm doing in the series. As with all four other videos, before I get into anything, I want to do the disclaimer. I'm not an electrical engineer, and I'm not an electrician. I'm strictly a Google electrician. I'm putting together my plans to do my basement refinish, and I'm trying to understand the circuits. And what I came across in my basement is that I have a situation that I've got in one sheath, in one cable, I've got a red, a black, a white, and a ground. So in other words, there's two hots sharing a neutral. And before I started doing anything with the circuits, I wanted to make sure that this house was built in like 1969, and I didn't know whether they had things wired properly or not. And before I started messing with the circuits, I wanted to make sure that things were wired properly so that I don't have a situation that we're overloading the shared neutral. It's getting too much current, it overheats, it melts the insulation, it starts a fire. I've got a problem in the house. So in this final video, I'm going to show the schematic, the diagram of what the circuit looks like. The previous video, I showed just a simple diagram, which would be what your typical thing is, and which is really what you want to be aiming for now, because I think nowadays, I think you're really not supposed to be running wire that's got shared neutrals on your circuits. But this is what I've got in my basement. So now I'm going to look at the situation, the representation of the situation that I have in my house, to just finish up this discussion and explain why it is that we wanted to see the current on the shared neutral go down when I turn the lights on my other circuit compared to when the furnace was running. So let's have a look at it. Okay, so what I'm drawing here, this is supposed to be the service panel. This is supposed to be the neutral. This is supposed to be the bus that the neutral gets wired into to complete the circuit. It doesn't matter what else we have here. If you just look at this part of the diagram, this would, forget that this is here, you would have like your hot and your neutral that comes back, your circuit is complete. What's different about our situation, if you remember from the first video when I was looking at the service panel, we actually have two 15 amp breakers that weren't side by side. And my concern is that they were on the same leg, which means that the current would have been running in the same direction. And so the current coming back on the neutral would have been additive instead of the difference. And so what we would potentially have, if I fully loaded both of these circuits, is we'd have 30 amps of current coming through a neutral that's only rated for 15 amps. And so I wanted to check that wasn't the case. And so I used the amp meter, and what I showed is that when I've got the load on both of the circuits, the current coming back through the shared neutral was actually the difference of those two currents. In other words, what happened is the amperage went down on the shared neutral when I added a load to the other circuit. So what does that look like? Why does that happen here? So your service panel, your circuit breakers, your two hots coming into your circuits. So what we have that's different from our first diagram is there's this shared neutral between our two circuits. And as I mentioned in the other video, that if I've got 10 amps coming through this circuit, then 10 amps needs to go back. Except that if I also have current on this circuit, when this is wired properly, what ends up happening is, if depending on where we are with the alternating current, let's pretend that the alternating current is running in this direction. That's what this shows on this circuit. So it goes here and it goes back there. Well, what's going to happen when this is wired properly is that this circuit is going to have the current running this direction through here. So while this hot is drawing the current and then pushing it back through the neutral, the other circuit is actually going to be pulling it through the neutral and then coming back through what would have been the hot. That's the situation that you want. That's the situation that we have. And that's why you end up seeing that if there's, like there was 8 amps on this circuit. Actually, I did that backwards. This was our furnace. So there was 8 amps running on this circuit being pulled through. And then I had some lights on here, which let's just say that this is the basement lights. Let's just say all the lights were drawing 1 amp. They're LEDs. They don't draw that much. So what would be happening is since it's going in this direction, there's like 1 amp that's headed in this direction from this circuit. Since this circuit is going in the opposite direction, it's pulling the 8 amps through here, and then the 8 amps would come back through here. So this is going to have 8 amps. This is going to have 1 amp. But what ends up happening here is since the circuit's going in this direction, there's 8 amps trying to go in this direction, 1 amp kind of like fighting back against it in the opposite direction. So the net amount on this shared neutral is actually only 7 amps. That's what we wanted to see, as opposed to the current on the shared neutral ending up being 9 amps. So that's what we saw, is that when I was running the furnace, it doesn't matter which direction we say this is going in because it's alternating current and they switch directions. So I'm just pretending that when we measured it, that this circuit was pulling the current in this direction. This circuit was pulling the current in this direction, which means that we've got the neutral going this way for that and the neutral going that way for the other one. So when I didn't have any load on the other circuit, this circuit was drawing 8 amps, which means there's 8 amps on the neutral. When I put a load on this drew 1 amp. And what ended up happening on the shared neutral is that the current reading actually went down instead of going up. And that's what I'm explaining in this diagram. Why does that happen? Because this is wired properly. They're out of phase. While one current is pulling the circuit clockwise, the other relative to like the neutral. While one circuit is pulling the current clockwise relative to the neutral, the other circuit is pulling the current counter clockwise relative to the neutral. And so it ends up being the difference. And that's what we want to see, so that this shared neutral doesn't get overloaded, and then it melts the sheathing, and then we have a fire on our hands. Hope all of this made sense to you. There's a lot of terms that I'm getting into that you don't really care about. All that you really care about is if you want to watch, I think it ends up being the 3rd video in the series, that I had the multimeter on the shared neutral, and when I loaded up an additional circuit, the current went down instead of going up on the shared neutral. Hope that was helpful for everybody.